Number of occurrence. So given a sorted array ARR of size n and a number x, you need to find the number of occurrences of x in ARR. So we are actually basically given an array in size is n, and we are also given a number, say x, and we need to find how many times this x occurred in this array. So let's check the sample test cases. So here we are having an array 1 1 2 2 2 2 2 3, and it's the size of n, and we need to count the how many times this 2 occurs. So it will be 1 1 2 3 4 times. 4 times this 2 occurs, so we need to return 4. In the next example, we need to count the number of 4, but here 4 is not present. So if the element is not present, then we need to give 0. So if we take this example, it is given in the question that it's a sorted array. So sorted array, this must be kept in, we need to keep this in mind that this is a already sorted array, and this is our given example 1 1 2 2 2 2 3. So we can do a linear search here, like a normal linear search. Since this is sorted, the same elements will be present at the next consecutively. Like we are here searching for, here x is equal to 2, so we are searching for 2. So we can do a check, like if array of I is equal to 0 or equal to 2, array of, that is where I is equal to 0 to n, where n is the size of this array, we can check whether array of I is equal to 2. So basically here we check array of 0 is equal to 2, no, it's equal to 1. We check whether array of 1 equal to 2, no, it's 1. We check array of 2 equal to 2, it's equal to 2. So we can have a counter, and we can just increment this counter. So if this is equal to 2, we can increment this counter. Now we can again just check whether this 2 is equal to array of 3 is equal to 2. Yes, so again the counter increment. This is equal to 2, counter increments. This is equal to 2, counter increments. Now we reach 3, which is not equal to 2. So we already have this counter value, so we can just return this counter value at the next time when array of I become not equal to 2. So this is a linear search, and here the time complexity will be of n, and space complexity, we are not making use of any extra space, so space complexity will be big of 1. So another approach is we can also just use a hash map. We can just go through this array once. We can count here we can say 1 is the key and 2 is the occurrence. So what is the number of times 1 occurs is 2. So we can store it as a hash key value pairs. So in the next time 2 is 4 and 3 is 1. Now we can just go through the keys or go through this hash map and check whether what is the count for this x. If the x is not present, that is if x is equal to null, if a null value is appeared, then we can just directly return 0. So here also, this hash map approach also, we have big O of n time complexity and big O of n space, because we are making use of extra hash map. So another thing, like we need to make note, like this is a sorted array. So can we do this better? Can we come up with an approach which runs better than this big O of n? So the one that is better than this big O of n is big O of log n approach. So this is sorted. So if we need a big O of log n approach, then we need to apply binary search. So binary search is the way, is the optimal approach that, for finding the how many time the 2 occurs. So how we can find using the binary search? So by using binary search, we can just locate where is this 2. Now suppose while doing the first iteration, we just found that let's say this is 0, this is 1, this is 2, this is 3, 4, 5, 6. These are the indexes. Suppose the first iteration, suppose we find that the 2 is present at index 4th index. Now we can reduce our search space and can search in this place in order to find what is the first occurrence where we find this 2. So the first time the 2 is occurring is at index 2. So we can find that index 2, the first occurrence of x, and here which is equal to 2 is 0, 1, second index. So we can find that by using the binary search. Same way, we can also find what is the rightmost index. That is the rightmost index, this 5, where 2 is occurring. So same way, if we get some value here, then we can reduce our search space to the right. That is, we can move our left to the middle plus 1 that we will be finding during the binary search. So the last occurrence, of x will be 5th index. So the result will be the final, that is the last occurrence minus first occurrence plus 1. So if we applies the same here also, it will be 5 minus 2 plus 1, which is equal to 3 plus 1, which is equal to 4. So 4 is the answer that we are looking for. So 4 is itself the answer. Now let's do this some more. So our example is 1, 1, 2, 2, 2, 2, 3. So let our low is equal to 0 and our high is equal to n minus 1, which is equal to 6. Let's also have some starting occurrence which is equal to minus 1 initially, and also ending occurrence which we can initialize it as minus 1, because we can use this value after the first binary search. If the value of the starting occurrence is still minus 1, then we can say that value is not present inside the array, so we can directly return 0 as explained here. Here we searches for 4. Here 4 is not present in this array, so we need to return 0. So that can be done using this. So so after first binary search, if the starting occurrence is still minus 1, then we can return 0 as the target is not present. So here our target is, or our x value is 2. So low is equal to 0, high is equal to 6. These are the initial values. So the first iteration, this is while low is less than or equal to high. So 0 is less than or equal to 6. Yes, so our middle will be low plus high minus low by 2. So this is the formula to find the middle. So 0 plus 6 minus 0 by 2, which is equal to 3. So 0, 1, 2, 3. So this array of middle, that is array of 3, if array of middle is equal to x, if it is equal to x, we are not sure that this is the leftmost, that is the first starting occurrence. Here the first starting occurrence is at 2, but we already found the element at index 3. So what we do means we move the right middle minus 1. So here what we will do means we make the starting occurrence equal to middle. We are not sure about that, so we just store that value here and we move right to middle minus 1. This happens when array of middle is equal to x. Now the other condition that may array is if array of middle is less than x. So if array of middle is less than x, then we need to move towards the right. So our left will be middle plus 1, or the else value is right is equal to middle minus 1. So these are the conditions that we are checking. So if we find an element, we are not satisfied with that, because we are for the first binary search we are looking for the leftmost, that is for this 2 which is at the index 2. So we are looking for that. So array of middle is equal to x. Here the middle is 3. We are not looking for 3, we are looking for 2. So we just reduce the search space to this one. Now it will be the search space will be here, and we will look for 2 again, and like that we will find this 2. So after doing that, after completing the whole binary search, our starting occurrence will appear to be 2. So our starting occurrence will be storing the value 2. Now in the next case, now we found the starting occurrence. Now we need to find the ending occurrence. So in order to find the ending occurrence, we reinitialize. Sorry, I just made this. This is high, this is low, and this is also high. So we reinitialize. Low is equal to 0, high is equal to length minus 1, that is n minus 1. So here it is 6. So high is equal to 6. Now same we do while low is less than or equal to high. We find the value of the middle. Middle is equal to low plus high minus low by 2. So while doing this, we will again get 3. So if array of middle is equal to x, that we are looking for. Now this time we are not looking for the starting. This time we are looking for this 2. So what we need to do, we located our 2 at third index. Now we move the left index, we reduce the search space, we move the left index to middle plus 1. So the left will be middle plus 1, and we just store ending occurrence equal to the middle value. Else it's the same as the above. If array of middle become less than x, then our left is equal to middle. Again I just it's low, this is also low, so our low is equal to middle plus 1, else our right is equal to our high is equal to middle minus 1. So now our ending occurrence will come to be 5. So now we just return ending occurrence minus starting occurrence plus 1. So this is the idea behind this. So we will be doing two binary searches. So one binary search is to find the starting index of the target, and the second binary search is to find the ending index of the target. So this will be having a big of log n, and this will also be having big O of log n time complexity, and we are not making use of any extra space complexity, so the total time complexity will be still be big O of log n. Space complexity will be big O of 1. So this is the idea, just doing binary search to find the starting index, doing the binary search to find the ending index, then just subtracting ending index minus starting index plus 1. So let's try this. So if just a pre-check, if our given array is null or the n is already equal to 0, we can just directly return 0. Since it's also not required, since the constraint is already given that it will start from 1, but it's better to do this. Now let's have our starting occurrence, which we told to initialize it as -1. Suppose it's because suppose if we didn't find the x in our array as explained here, this example, here we will not find 4 after completing the first binary search. So our starting occurrence value will still be -1. So we can just check it before starting the second binary search whether the value changed from -1 or not. If it is still in -1, then we find that x is not present inside the array, so we need to return 0. So now we have ending occurrence, which is also -1. Now we can have our low, which is at 0. We can have our high, which is at n-1. So now we can do our binary search. So this is the first binary search. Okay, to find the starting position. So while low is less than or equal to high, we use this formula to find the middle. Middle is equal to low plus high minus low by 2. So int middle is equal to low plus high minus low by 2. Now if array of middle is equal to x, then we find a value, that is the value is present inside. So our starting occurrence may be this middle, we are not sure, so we just reduce the search space. We need to reduce the search space towards the left, so middle -1. Else if array of middle is less than x, so there is no point of checking with the left part. Now we move towards the right, so we move the left to the middle +1. Else right is equal to middle -1. So now we are done with the first binary search to find the starting position. Now as we told earlier, we can just check whether the starting occurrence is still equal to -1. If it is still equal to -1, pre-check whether we find x or target. So if it is still equal to -1, then it is not present, so there will not be any occurrence, so 0. Now we just reinitialize low to 0 and high to n-1, because we are going to start the second binary search. So second binary search to find the ending position. So while low is less than or equal to high, we again apply the same formula to find the middle, low plus high minus low by 2. Now if we find array of middle equal to x, so the ending occurrence can be middle, but we are not sure. So what we do, we move the search space towards the right. So we move the left pointer. Again I just changes everything to left and right. I always make mistake regarding this. High, 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 high. So this is low. We move our low to the right part. Now the other two conditions are same. It's array of middle less than x. So our low is equal to middle plus 1, else our high is equal to middle minus 1. So now we got both ending and starting position of x. Just subtract and add 1. Why add 1? Because this is a 0 indexed array. So we need to add 1. Like you can just go through one example and you can find that. So I can also just show that. So if ending occurrence minus, if I just return ending occurrence minus starting occurrence, I can say we can see that we will be lagging by 1. So we will be getting value only 3. So we need to add this one. So the sample test case is passing, is giving output 4. Let's submit. Yes, it's solved successfully. So here the expected time complexity is big of line. That's where we need to think about the binary search. Also the first thing that we need to notice, it is a sorted array. So in most of the problems, when it is given a sorted array and we are working with some target or some searching values, then our preference is for the binary search. So yeah, the time complexity is big of log n and the space complexity is big of 1.